Hello everyone.
Hello, good morning.
Good morning, sir.
Morning, sir.
Good morning to everyone. My name is
I'm
Vasu.
not able to hear you. Just a minute.
Okay, sir.
Just give me a minute. Yes, please. Can you hear me?
Yes, sir. I can hear you.
Uh, I am not able to hear. I think there is some issue. Let me reconnect. Just give me a minute.
Okay, sir. Good morning, sir.
Yeah. Good morning, Vasudha. Very good morning. Good morning to everyone. Sorry, there was some delay. I am not sure. Like I was not able to let in. So thank you so much for patience. Yes, please.
Okay, thank you, sir. A very good morning to all of you. Let me introduce you all to Mr. Rajesh Singla, who is an eminent in the field of data science and has a working knowledge in machine learning, Python, Tableau, Power BI, and cloud integrations. Apart from that, he also has a vast and comprehensive experience of 10 years in the field of data science and analytics. Mr. Singla started his career with working at Nokia Siemens Network Company. Thereafter, he switched to Ericsson for a couple of years and then moved to Vodafone and Colfridge. And currently, he is a technical lead in NLP at Accelera. Today, he will be delivering a lecture to us on the topic natural language processing techniques and its usage in industry. As we all know, natural language processing techniques and its usage in industry is referred to as NLP and is current and latest technique, and it is a currently a latest technique in the field of AI, and many and technological based companies to make better decisions based on unstructured data. Mr. Singla will share with us his knowledge of NLP in terms of pre processing steps, stemmings, embeddings, and vectorization. Also, he, he shall share with us few case based problems faced in real world life while working along with its possible solutions. So, I request you all to pay attention and gain some fruitful knowledge from him. Thank you, sir. You may continue.
Thank you, Vasudha. Thank you so much. So, I would like this session to be interactive. So, if anyone is having any questions or feel, so they can raise their hands and they can interrupt me in between. So, thank you for telling about me, letting people know. Thank you so much. So, I'll start sharing my screen. Just let me know when you guys are able to see.
Okay, sir.
Can you see the screen?
Yes, sir, it's visible.
Okay. So today, I'll take you through like what particularly NLP is being used in, you can say industry and their applications, and what the problems that we face, like when we solve any such problems. Okay, so agenda for today will be like we'll cover basics, so like basic terminologies which is being used in the industry and academics as well. Then NLP applications and its usage. Once we are done with quite NLP applications, like what are the main applications, then we'll go for the industry applications, so which are being used throughout the industry. So that varies from manufacturing to food and healthcare and everything. Uh, Post industry applications. So we'll see like what problems we face in industry and what might be their solutions. Okay, so I'll try to share my knowledge, whatever I have, like I've gathered through my experience. So there might be situation like I might not be sure about some answers or something. So yeah, so that might happen. So if we speak about artificial intelligence, so it is a broad discipline. So where we have machines which learn about the data and try to predict from that. Okay, so artificial intelligence is not only in computer science, so that varies in the fields of mechanical to other fields as well. Okay, so if you speak about machine learning, so machine learning is about learning from the experience. So where we have the data, we try to understand the relations between those data points and those features, and then we try to extract some knowledge or gain knowledge out of that particular data. Okay, then when we coming to deep learning, so it refers to learning more when we have a large amount of data. So and like deep learning is basically more advanced than machine learning, so which is again ANN and other things. So artificial neural networks is it just works like a human neural network. So we have space, then we have neurons and all those things. So that is particularly based on how our human brain works. So that is artificial neural network. And again, like ANN is being said as unexplainable AI. In machine learning, so we do have algorithms for different problems. Like we have, if we have a prediction, we have to predict some continuous data. Then we have regression algorithms. If you want to classify some things, then we have classification algorithms like logistic and other things. But particularly in ANN, so these are unexplainable. So we try to uh, you can say make our problem solve through those neurons. So we have various neurons, various layers, which start from input layer, hidden layer, and then output layer as well. Okay, so then coming to natural language processing. So natural language processing is how a human interacts with machines and how that can be used as you can say as a trigger to learn machine like what it does. For example, as we read some newspaper, we try to extract information from that. Okay, so that is natural. So we speak with each other. So that is a natural language. Or you can say when we chat with someone, maybe through WhatsApp or through Facebook, so that is the natural language processing. So this NLP particularly is about understanding that thing, because if we speak or if we talk about this natural language, so that do have a formal, you can say, semantic or syntactic uh, uh, formation, but we do not always speak or write in that way. Okay, so there are a lot of elements which are being added to NLP when that is being processed, and that's why it's a wide field, like where a lot of research to be done, like, and that is happening already. Then if I speak about automatic speech recognition, so it is about techniques which identify and process human voice. So this is again, you can say, comes along with natural language processing, because like it is again with the how people interact and how people speak. So that is with again with natural language. Now, if I speak about the AI ecosystem, so AI is a vast field where the subsets are machine learning and deep learning. So, particularly area of ASR or NLP, so that is, you can say, that is intervened along with machine learning and deep learning. Okay, so NLP is mostly about unstructured data. Okay, so that is not structured. While machine learning, we generally speak large amount of training data. Okay, then compute power. So earlier, what used to be like you can say in 90s or early 2000s, so compute power is was less as compared to it is available today. Okay, so even in our phones we do have like 12 to 16 GBs of RAM, but earlier it used to be hardly like 1 GB of RAM, and that's the reason we are able to train the models very you can say with less amount of time and quickly. Okay, and as we are advancing So we are the more number of models, or you can say the advanced models and algorithms are being used or are being identified, so which can solve the problems which are particularly coming in the field of NLP. So if I particularly speak about natural language processing, so these are uh, the technical things which you need to learn, particularly if you're looking to make a future, particularly in NLP. And this is from like bottom to top. So when we have any of the textual information or textual data, okay, so the first thing like you need to do on that particular data is pre-processing. Okay, so that textual data might the first thing is like machine will not understand textual data. Okay, machine will only understand the numerical data. So how can you make the textual information into numeric one? So that's the main thing. So there are a lot of ways through which we can process our textual data and convert it into a matrix, or you can say embeddings of numerical values, which might further be used for machine learning algorithms or even for deep learning algorithms. Okay, so that is the first part that we need to do in case of textual information. But before converting it into numerical vectors or matrices, so we need to pre-process the data. Okay, by pre-processing, what we mean is so there might be informations available in data which might not be useful for a model. Okay, uh, for example, like there are some words. If I say uh, I'm living in Delhi. Okay, so okay, M is kind of word that will not add any value to that particular sentence. Okay, so these kind of words are called as stop words. So before processing, we need to remove the stop words. Okay. So the first part that we do is a text pre-processing that you call is a level one. We do a tokenization. Okay. Tokenization means we break the complete sentence of input sentence into tokens. By token, I means like the number of words present in that particular sentence. Okay. So for example, I am living in Delhi. So I would be a one token. I am would be a one token. So similar way, like there will be various tokens. Then, then there is a process which is called as lemmatization or stemming. So lemmatization and stemming are the two approaches which you can use to simplify, or you can say convert a particular word into a root word, base root word, you can say. Okay, so what I mean by base root word is, for example, like if I speak, there are two keywords or two words in the same sentence. One is ran and another one is running. Okay, so the base word for both of these words is run. Okay, if we directly give these words to model, so it like they're having the same root word, but it have to make two different vectors for the same word. And this is just I'm giving an example of two words which are having the same base. So there might be multiple words which are having the same base, but they have different uh, you can say vocabulary in sense of written down of word. So in that case, we need to convert them into the base root word. So that in that case, we are having two processes: stemming and lemmatization. So we stemming is somehow faster as compared to lemmatization. That is because stemming is rule based, and that converts each word into base word based on some rules. Okay, for example, running, I need to remove ing from the last. So that is kind of what stemming does. Lemmatization, however, gives you the word which is particularly, you can say, have some meaning as well. Okay, so it in stemming, there might be situations where the root word might not have any meaning. But in case of lemmatization, so this is based on part of speech tagging plus other information. So lemmatization is particularly based on the model which it generates the root word based on the pos tag and other information, and it does have a meaning as well in case of lemmatization. So it actually depends which particular technique you need to apply while doing a stemming or lemmatization. So that depends on the business problem. So third thing is stop word removal. As I was telling, like there might be a lot of stop words which are present in the text. So we need to remove those stop words as well, because that would not add any value to the model, but somehow it will add overheads to your model and it will increase the complexity of the model. So this is the first level of pre-processing that need to be done. So now you have done tokenization, lemmatization, and stop word removal. Okay. So once you are done with this particular part, so then there are various techniques which we can apply to convert these into numerical data. Okay, some of them are bag of words, TF-IDF, unigrams and diagrams. So I would not go in much detail. So if you guys have any question on these particular things, so I'll be happy to answer that. So that we may take. So but these are some techniques which are done, and each particular techniques have some limitations, and that's why there has been you can say improvement in the technique, and the new technique has come. For example, like if I speak about back of words, and back of words that have information about the how many times a number of word is coming in a particular sentence, but it doesn't give any weightage to the number of sentence which number of words which are occurring frequently or anything. So that's the reason TF-IDF was come. It is basically takes information depending on the number of time a particular word is coming. Okay, and how many documents it is coming. So if a word is occurring frequently in all the documents, okay, for example, we are having 100 documents and a word is occurring in all the 100 documents, so that will have less weightage, because that is, you can, something common word that is coming to every uh, document. So that will not help model to learn anything, okay, because it is common. So it gives weightage to less frequently less occurring words which are particular to that particular document. So if we particular give more weightage to those words which are not frequently occurring, so that definitely will add value to the model. Then we have unigrams and diagrams. Unigram and diagrams are like how we take a complete sentence. Okay, for example, natural language. If we take this sentence in a unigram, so we'll take one word at a time, like natural language analysis with NLTK. But if we speak about diagrams means two. So we'll take two words at a time, natural language, then we can take language analysis, then analysis with, and with NLTK. Okay, so this way it will add some more informations to the words we are taking together. Okay, so that is the difference between these two. Then once like these are some of the basic techniques which we can use for converting a text into numerical format. Then we are having some advanced techniques where we speak about word to vector. Okay, so word to vector is something like where we give a particular word to a model, and it converts that particular word to a vector. Okay, so vector might be many dimensions. Okay, so there are various ways further for word to vector. So there is one hot encoding, and there are other ways. And so Zensim is a one library which you can use to convert a word into a vector, which is having a particular defined dimension. Okay, and then we have word to vec, and yeah, so the Zensim, those are the same thing. So these are some techniques where we convert a word into vectors. So from these things, so we can directly have we will input the complete sentence containing words, and we can have a output matrix which contains information about these words which are occurring in the corpus. Okay, so once you are done with this particular part, okay, so then so at this particular point we are having our features as a numerical features which we can apply to machine learning use case, or you can say deep learning use case. Okay, so then you can apply these to machine learning and even to your artificial neural networks. So these are you can say building blocks for learning NLP. So once this is done, so then there are models which speak about sequence to sequence data. Sequence to sequence means I'll take an example which you might have also faced, like when you go to Google. Okay, when you try typing something, maybe how is the weather in, okay, so what Google tries, it tries to auto populate the next word. Okay, so that is something which is happening with the help of NLP. Okay, so it is kind of sequence to sequence model where we have a sequence of words being added, and it tries to predict the future word. Okay, so it might be wrong sometimes, but if you see like 70 to 80% cases, it will auto populate two or three options which are of your use, or which you might be thinking in your mind, yeah, I want to search this particular line or this particular thing on the Google. So that is how it works. So it has taken a lot of data from internet or from research, and it has modeled in a particular way that the sequence input which you are entering, it tries to predict the next word which a user might be looking for. That is how it works. So all these models which you speak about, recurrent neural network, LSTM, and GRU, so these are sequence to sequence models where we have sequence of information and output. So output might be a sequence of data, like I spoke in case of Google, where we input words and it predicts the next word. Or output might be a, you can say, a single some a single classification kind of thing, like where whether this is a particular for example, I've given an input text to the model, and a sequence input text to the model which might be in German, and the model might predict, yes, this is a German language, so it might be a language like German or English. So that in that case, so it will be a single output where we have only a single output rather than sequence. Other example of sequence to sequence model can be, you can say, where we have input as a matrix or a single input, and the output might be sequence. Okay, for this particular thing, if I speak, so you might think of any picture which contains information, or you can say a dog or cat, they are playing in on road or in some of the park. Okay, so we give this information to the model, and model tries to caption this picture. Okay, so it tries to gather information whatever is available in the picture. It might give, yeah, in the output it might give dog and cat. They are available, or they are in park, or they are on the road, so that particular information. So in this case, so input we are having as a picture which contains some information, and output is kind of sequence of words or text which contain information. Okay, so this way, these are sequence to sequence models. Then there are a higher pre-processing, text pre-processing, which you can say is word embeddings. Okay, so word is like the same thing, but word embedding is something that is a kind of higher level than word to X. Word embedding is something when you try to embed the words based on the vectors. For example, like if I speak about like when we say king is to queen, okay, so that means that they do have some relation between them or informations. So that information should be embedded within the vectors which we are presenting to a particular word. Okay, so this is how word embedding works. So that create embeddings between the words. So in word embeddings, we do have a matrix which contain information about a word. Okay, uh, and it contains the informations that this particular word might be related to other words, in how, like in how many ways they are embedded or something like that. So that is how this word embeddings is being used. Similar way, like you can say, like India capital is Delhi. So those things. So it contains all those informations. Okay. So the benefit point here is we do have less number of dimensions as compared to if you are going for one hot encoding and other things. And if you are able to reduce the number of dimensions for your features, that will highly impact, you can say, the learning of your model and complexity of that model. So at the large number of features you have, more time it will take and it will be complex to learn. and less number of dimensions, so it would help your model to fit well. Okay, so as you spoke about sequence to sequence, about LSTM, recurrent neural network, GRU, then we do have bidirectional LSTM, recurrent neural network, then encoder and decoder attention models. Okay, so what was the problem with these recurrent neural network and LSTM was, like, we are giving a particular input text, but we were not having particular attention to particular keyword or the things that are present in the sentence. Okay, if I speak like I bought a new car, the car name is this and those. So if I give this to particular this model, so it might take uh, some information out of it. But if we speak about attention models, what it does, it gives more weightage to particular keywords which look important to the model. Okay, apart from the way it was working in RNN and LSTM, so it will add more weightage to those particular keywords that will further help model to build it better. Okay, so that is how attention model works, and then we gave it transformers and birds. So mm, these are the models. You can see transformers are a way how that is being used in today's case, where we use BERT, or there are some other models as well, like pre-trained model, GPT, GPT-1, GPT-2, GPT-3. So these BERT particularly, or GPT, they are based on transformers. Okay. So what transformer does is it tries to create a context vector out of your input sequence. Okay, so in input you have some textual data, so it tries to convert that textual information into a context vector. Okay, so we do have a model which is like, we do have part which is called as encoder, we do have another part which is called as, you can say, decoder. Okay, so between encoder to decoder, so transformers tries to convert, you can see, the input sequence into a context vector, and then that context vector is being passed to decoder, which further gives information to your output, you can say, matrix or vector. Okay, so bird is basically is used, or you can say was developed by Google team. Okay, and this is particularly bidirectional encoder representation for transformers. So what it does is it tries to capture information from the input text given. Okay, so we do give the direct textual information. We do not pre-process or anything on these models. So we directly give our input to the model, and it gives us an encoder, you can say, context vector, which we can apply further to deep learning algorithm or other algorithm, or you can say even machine learning algorithms, because those particular output can be used as the features. Okay, so that is how and they are able to perform very well uh, with respect to textual information, and that is being used like for most of the cases as well. And so any questions till now? Like, anyone want to ask anything till now? So we are good to go.
Hello. Good
Yes.
morning, sir.
Yeah. Good morning.
Sir, I am doing a project in Transformer right now. I am
Mm-hmm.
MTech second year student,
Okay.
and I am doing for Indian regional languages classification problem. It is.
Okay.
So I am using BERT, Roberta, and Indeed BERT by
Mm-hmm.
IIT class. So I want to do fine tuning in this.
Okay.
What type of layer I can add?
So, like, how much accuracy you're getting as of now? Like, if we speak
At
about,
60. I am at 60%.
so what is 60? Like, accuracy, F1 score, or the precision and recall?
This is the accuracy, test accuracy.
Okay. So there are various like parameters which you can add. Yeah, like for example, so what amount of text you have? If I speak about the feature which you have as an input.
Uh,
Okay,
I
so
have target and label.
mm-hmm.
This is a government project, so I can't disclose exactly. But I have target and a feature. Two columns are there.
Okay. No, like by text I means like amount of text in the sense, like in a particular,
Uh,
if I speak about a particular data point. So what is the maximum length of text you get? Like maybe 2 lines, 3 lines, 4 lines,
I
something like
have 25,000 lines.
25,000 lines. That is complete data set, right?
Yes.
So in one line, what is the maximum amount of text you have? Like it might be 200 words, 300 words.
Yeah, this is approximately 30 word maximum.
Okay. And do you have any numerical information also in that, like maybe some
Yes.
numbers or those?
Yes, I have numerical information.
Okay, okay. Okay, so I can suggest, so that might take some time. So I can connect with you maybe offline, okay?
Okay, sure.
Or after, like once I'm done with this, then I can suggest you the things which you can do on that part,
Sure, sir.
right?
Okay. Thank you, sir.
Welcome. So this was like how you can prepare particularly for NLP. Then, if we come to NLP tasks which are there in the industry or which are being used, so one is you can say machine translation, where we try to convert from one language to another. For example, like if we speak about English to French, or English to German, or the vice versa. So that is the one task that we are capable to do using you can say NLP techniques. Okay. Then we are having information retrieval. Information retrieval is something which like the information is present in document, or these document might be PDF, these might be a Word file, or it might be from some email information, or you can say email file. Okay. So we tries to extract what is available in that particular document or email, and we may use that for further analysis or further, you can say, model training or something, so that might be used. I'll show you an example of how information retrieval is being used. Then we have sentiment analysis. Sentiment analysis is something when people speak, particularly on social media or about some product. Okay, so if you speak about product-based companies, when they launch any product, so they get feedback. Okay, so it is quite difficult to read each and every feedback and have the outcome as a like what people perceive from that. So in that way, sentiment analysis plays a very important role. So when you have large amount of data and when you do some sentiment analysis on that, so it can tell you what people are speaking about your product, whether they are liking it, they are disliking it. And we can go further onto this, like after sentiment analysis we can do a topic modeling. We can do other NLP tasks which might tell you which particular points you need to focus in your product. For example, like if people are speaking good about your product, so what particular point they are speaking good about, okay? Or if they are speaking bad, so what particular area we need to focus on, okay? For example, like if I speak about phone, okay, if I take phone reviews from Flipkart or Amazon. Okay, so they might speak good about the battery of that particular phone, or they might speak about the speed of the phone, like they are good, and they might speak about bad about the customer service. So those informations you can extract, because the number of times people are writing on the feedback, so you're getting more informations, and from there you might get insights from that particular data. So information extraction from various documents or from various sources, and you can say like from those information, so we may able to uh, get inferences which might be helpful in research, or you can say for your internal uses. Then we have question and answering. Question and answering is something when you ask a robot or something some questions, and that give you answer. Okay, this is something you can say more towards chatbots which are being used these days. Okay, so everyone does Zomato, Swiggy these days. So when you have any problem with your food order, you tries to go to the chat. Okay, so and you see the responses in that chat window. Okay, so that will automatically ask like which particular order you are speaking about. Okay, select a particular order, it will give you some predefined answers. Okay, so was the food bad, or was it something about delivery? And once you select a particular options, it will give you some further information. Okay, and when you see like 90% of the time you are able to solve your problem using that chatbot, and there might be some 10% cases where you're actually speaking with some agent. Okay, so that is how NLP being used in today's world in the industry, where workforce is being limited, where you are interacting directly with a person, and you are interacting more with a machine, because if you are able to solve 9% of the problems using machine, so in only 10% of the cases the people are required where we need to speak. Okay, even in case like you are doing that chatbot, you write something, so it will give you a if it understand some words from that text which you return, it tries to give you those particular options. Okay, for example, rather than hitting on the buttons, or you can say hitting on the text which it gave you, you write I want refund, so it will try to give you information about refund. Okay, it will give you some 2 3 options about refund. Okay, so that is how that learns the thing, that like that model is trained. So if there is a no predefined question from user, it tries to gather information from the given input by user, and then it gives you information on that particular part. So that is how it works. Similar way, like other chatbots are working. So so that is how question answering sessions, or you can say that those things are working these days. Okay, so if I speak about information retrieval. Okay, so this is this is a simple example of retrieving information. Okay, so when people is asking when will you meet with me? Okay, so then the guy is replying, I've decided to meet tomorrow at 10 a.m. in library. Okay, so if I speak about this particular sentence, I do have what information I do have. I have information about the day, like tomorrow it might be some date, time, and the place. Okay, so this particular information I get from this particular sentence. So this is a very basic problem where we can have entity recognition using various models, maybe Spacey or some other model, where you can identify like what particular time or what particular place. So it identifies the entity present in a sentence. It will give you like 10 a.m. is the time, library is a place, or something like which you can refer to further. Okay, so similar way, like this way. This example I've taken from maybe some snapshot from Google. So this is kind of tomorrow, and with the system fed date, you can fetch that particular date, time you can fetch, and then the place library. So this is a simple example of information retrieval. Okay, this is again some information which is might be written in Bengali, or uh, I'm not sure, like, but yeah. So this from this what you can say, like what NLP does, it converts this particular information into English, and it tries to capture uh, the information from this particular text. Okay, so what is the particular event is a database presentation. What is the time? So it's 11:30 a.m. And what is the information available in this particular text? Okay, so this way how information retrieval works. Now, there is another example where we speak about machine translation. So this is something I was speaking while I was speaking for sequence to sequence models. So you give sequence information like one word, another word, and then another word, and then model tries to predict the output based on that particular input. Okay, so it gives you also like again a sequence to sequence. The best example I can tell you of this, if you might have come through, if you have tried Google Translation any of the time. Okay, when you tries to type anything on Google Translation, maybe from English to French or English to German, or any language. Okay, so you type one word, it gives you a translation of that particular word. You try another word, like you have written two words, so the final information in the translated task might change. Okay, for example, like you've written I in the first one, it will come as I, but when you add something another thing, so it changes the output sequence as well, right? So that is how these particular models work. So you give input sequence, you get output sequence, and that keeps on changing. That tries to that model tries to predict more accurately with respect to your information, because in the first instance, it was having only one particular word which you need to translate it. When you entered second, so it has two words now. So in that particular dictionary or in that particular language grammatically. So it tries to predict according to that thing how it should be written. So that is how it works. Now this is about sentiment analysis. So sentiment analysis basically works on the keywords like which are there in the particular sentence. It tries to capture the positive words, then neutral, and then negative words. Okay. So this is very basic example. So as I was speaking, so there are research which is going on to understand the sarcasm within these uh, uh, text information. So you can say feedbacks or reviews. And if a user is posting something with emoticons or those things, so that again that is again like the work is going on that particular part. So this is another example where NLP is being used AI assistants. So you speak something to Alexa or Google Assistant or Bixby from Samsung. You get the information. So you speak to Google. Okay, Google, do this. Okay. So what it does, it tries to first convert your audio to some text. Okay. Then based on the models, it try to capture what best it can capture using the internet or using the predefined models which it has used in the backend. Okay, so this is the way like these has been working. This is again example Google Auto Suggest where I was speaking earlier as well, where we type something and it gives you 3 or 4 options, which you might be thinking or which may be related to that particular text which you've written. Okay, so this again is sequence information. So you've written 4 words and it tries to predict the future instances or future words which you might be thinking of. Okay, so this is again based on the training the model has been trained on based on the search that Google has been done, like or that has been done on Google. Okay, so it tries to capture the information and build the model based on that. Another example, you might have come through InShorts, or you might have this particular app in your mobile. So InShorts is an Indian company. It has used again NLP techniques. So what it does is it converts your news or a particular news in just 60 words. Okay, so rather than reading the complete, you can say 2 hours to read that particular news article. Okay, so InShorts has made use of they have used best in class models to get the summarization from that particular article, and it tries to give, and it has it has taken a great place in the industry with respect to, if I speak particularly in case of news industry. So it has taken a great place by using this particular each word has a limit of 60, so it won't contain any information which is more than 60 words. Okay, so how can you convert those 300 words into 60? So that is how the models has been working. So the most important words that contains textual information as well. So it only doesn't contain the words, it contains complete sentences which has been modified from the original sentence, but it conveys that particular information which was being conveyed with those 300 words. Okay, so these models might not work perfect, but they are just you can say close to perfect. Okay, so they are having good accuracy. So there might be cases where these models might fail in some scenarios, and that is with that happens. Okay, so that is with every model that we train, because you cannot get 100% accuracy and all those figures. Okay, so this was something like where we are using industry. Okay, so if I speak about we use, so the first thing that whenever you are going to any industry for particularly in any of the field for AI ML, so the first thing is you need to understand the business problem. So because many of the time it happens the people at higher management, or you can say at a level where they are in a hurry to solve the problem, and and the data might not be available so much that you can make a judgment out of it. Okay, so the first very thing is you need to articulate that particular objective uh, of your particular application. So it might be NLP, AI, or ML. So you need to understand what actually business needs, and once you have that particular information, so then you can align those particular users to your requirements. For example, so there might be things where management might be thinking, yes, this could happen with respect to this data, but from your point of view or from a data science point of view, you need some other information. So there are some limitations which you may not apply to that data. So those things you need to highlight, put in front, like this is the thing which can be done with this data, and these things I can try and I can come with solution. But you need to be like confident on those things, yes, and you need to clear those things, technical and business things, during the starting phase of your project. The second most important part is data set. So we do have data sets which are available on internet, which are publicly available. Okay, but if we speak about a particular business problem in any of the company or organizations, so that data might not be available much, or you can say a proper data might not be available. So one thing is you have less amount of data. Another thing is you have data, but you need to prepare, you can say pre-process, pre-prepare the data before doing some work on it. So, okay. So the second case where you have data and where you can apply some techniques, and you can use the data, so that somehow you can manage. But if you are having less amount of data, or you do not have enough data, so that might be a problem, because if you don't have enough data, so your model will not be able to train accurately. Okay, so in that case you might need to use synthetic data. So there are some techniques which you can use to create synthetic data, maybe oversampling and all those things, all those techniques. So that is one way. Apart from that is you can create some data by your own, if that can be done. And but these things you need to clearly tell your stakeholders, like this is the thing we are doing with less amount of data. And so in those cases, so your accuracy and other parameters, when we evaluate the metrics, final metrics, that might be hampered. So that is the thing. So with respect to data, so data is a very important aspect. And even like if, sometimes, or in cases, even 70 to 80% of your time goes into preparing your data, converting the data into a set, or you can say vectors, which you can build into your model. So that is most of the time goes into. Okay, so model preparations and all the other things that take time, but it doesn't take much time as compared to data set preparing in many of the cases. The next point is, if you're working in a particular industry in a particular, you can say, continent or country, you need to check for regulatory guidelines. Okay, if there is any with respect to that industry, because there are cases, or you can say there are scenarios where in some countries they do not allow some work on the informations which are related to individuals, maybe their health records. For example, I'm taking case of healthcare industry, like in case of health records or electronic health records. So you need to take care, and you must comply with those particular guidelines, because that might create issue for you in a longer run, if you do not take care of these things. Okay, so once you are done with these particular part, you need to check like which particular model or which particular techniques you need to apply to your data, to the available data, and like whether you need the GPUs or not. Okay, so those things. So this is the industry practice. If I speak more about learning perspective, like how you want to prepare yourself for industry or those things, so I would suggest like to go through the public data sets which are available on the internet. Try working on those data sets, try working on different problems which are there. Okay, so try building a model and deploy them if you can, using cloud or some other technologies, because cloud is one thing that is uh, being used in every industry now. So people are moving away from on premises server and they are moving towards cloud, uh, where like which so majorly like cloud providers which are being used: Azure, Microsoft Azure, Amazon AWS, and GCP as well, like Google. Okay, so Alibaba is also one, but these are the major ones which are being used. So in industry, so they like model, they try to solve the business problem, and then deployment is being done using cloud platforms. So that is how the things are working. Okay, so I try to cover most of the aspects. So I would love to hear from you guys, and any questions, or we can discuss any of the case studies if you want. Thank you so much.
Yes, sir. I do have a question.
Yes.
So, very good afternoon, sir. Nikhil this side. So, I want to ask like the complete hierarchy that is going on in the research as well right now.
Mhm.
That somehow CV and NLP are merging if we see the diffusion models. So I wanted to ask you like your perspective, like from here, where we will be the next step regarding the NLP or NLP plus CV, if we say the merging criteria. Because if we see on the NLP side, there were like RNN, then LSTM,
Mhm.
then some approaches like BERT, distill BERT did came. So and on the CV side, if we say DALE 2 also came, and now diffusion models are there. So,
Right.
what according to you will be the next thing after this?
As per me, so there are a lot of research that is going on where we are using CV along with the NLP. Okay, so there might be situations like where we are able to leverage the data which we are having from the deep learning technologies on particularly CV. So if we speak about uh, images or videos data, and when we speak about modeling them, okay, so we have various transfer learning techniques or models which are already there. Okay, so what I feel is there might be a point, or you can say the research which is ongoing, they might create something or models which may leverage both of these things, like one from deep learning and from NLP, that might be used in that particular scenario.
Okay, sir. And sir, one more question. Like, do you know, like, is there any state of the art thing that is capable of summarizing the complete fictional book without losing the sensitive information?
So summarization, so there are BERT summarizer, or like there are two type of summarizations, which is like abstractive and so you can try BERT. I'm not sure about like the amount of information that it will lose, but yes, there are state of art models like BERT summarizer you can use. And if you try to you what you can do is you can go on Hugging Face. So if you have heard about it, so Hugging Face is something like they have pre-trained models on different aspects, or you can say different problems which might be useful. So you can try on that particular site, and you can find some pre-trained models which might be useful for you. But I've used BERT summarizer, so that works quite well. So as you mentioned, it's fictional thing, so I'm not sure whether like it will work perfect or not.
Okay, sir.
Sir, I have a question.
Yes, Manish, please.
Sir, for English, we are having stemming, stop words are there, libraries are there, corpus is there. Now, if somebody has to work in some Indian languages, then what do you suggest? How to go about that?
Indian languages, so there is particularly work is being like work has been done and ongoing, but there are libraries, or you can say embeddings which are already there for Indian languages. Okay, so I don't remember the name exactly, but I'll search and I'll text to you. But there is already work that is being happening in Indian languages. So there are researchers or scientists which are working on that, and they have developed some models as well. For if you see about like Google or some other. So they even have mostly all the Indian languages which are available on Google. Okay, so that work is already done, and there are libraries or you can say models which we can use for that those languages. So that are there. I can text you like maybe after searching something in this.
Uh, yeah, Rajesh, this is Puneet here.
Yeah, hi Puneet.
I wanted to ask that is this NLP is being used for changing this? Because NLP is mostly working on unstructured data.
Mm-hmm.
So is it that we are using it to somehow convert it into almost data into a structured one, and so that we can process it later on, do the data analysis and all.
Mm-hmm.
So is it that being used for making unstructured data structured?
No, we are not making it kind of a structure. So there are some applications which you can say, but we are trying to convert this unstructured data into vectors, which can be used for further modeling. Okay, so what is the difference between structured and these vectors? Is structured data is something like you have uh, your complete features, or you can say information as that part of features which you can. Have or relate information to. Okay, but in case of NLP, when you have vectors or matrices, so you won't be able to, you can say, not analyze, get that information from those particular vectors with if you see them directly. So that only model can be trained over that part. So we are converting that particular unstructured data into a structured format which can be used for further model training. You can say that thing.
So somehow something intermediate we are getting for now. Yeah.
Yes, so similar structured, you can say if from that text, because that text can never be converted, because if you convert that text into some other text, so that will lose information, right? So there is
Yeah.
no sense in converting that text to some other text which a person can read or something. But yes, those particular features or information which is available in that particular text is useful, and that should be used to model a particular algorithm or something.
Yeah. Fine, fine. That answers my question. Thank you.
Welcome.
Yeah. Hello, Rajesh. I have got one very contradict question I can say. See, I would
Mhm.
like to know when this NLP will fail. I want the cases so that NLP should not work. Let me elaborate on the question, like why I am
Mhm.
interested in this. See, as you know, because of Corona, almost all our teaching has been made online.
Mhm.
So I was working on a platform where we can able to conduct the quiz in a proof cheat manner.
Okay.
So in that case, what happened is like when we created a platform, like we have made different techniques like randomized questions, timed questions. There are two cases we were not able to do anything for it. One of the thing is deal with this NLP. Another
Mhm.
one is something like whenever we send a quiz, like they can take a photo in Google Lens and it will convert it to text and quickly you can search it. Another problem we have faced is like again Google Assistant. When they search it in Google Assistant, they can get it very easily. So I would like to know, is there any way we can frame a question so that when they read the question it should not give you the search directly. I hope you got my question.
Yes, I got your question. So you are looking for some application or something which people, or you can say students, might not capture direct information
Yeah,
from that particular
yeah,
part.
exactly.
So look, like in today's era, so this is you can say one of the shortcomings
Mm.
when we are working from home, or like when we are working remotely. So that is with you can say every industry, or particularly with teaching, because if you maybe generate any application or something on system, because like there are systems which come with inbuilt security where you might not be able to capture the screenshot, but that is through your laptop or desktop. But The same thing can be done from mobile, like you said. Okay, so those shortcomings is something you I do not think there is a some solid proof solution for that, because if you capture that information from your mobile, and from mobile you can convert the text in like the complete image into text, and you can search it on Google, right, from other device.
Yeah.
So you cannot go away with that. So I do not think as of now, like, because that is a limitation. There is only one thing that may happen or might work, is like when you have systems in place which captures the movement of user through camera,
Hmm.
and that too like a small changes when a user may try to capture information from mobile through something like that. So you can say handling movements or keeping track on the movements of the user. So in that case, if you train some model, so that might be useful in that case. But
Okay.
apart from that, if you try maybe other techniques, so that's what I think.
Okay. Thank you.
Okay.
Sir, I have another question.
Yes, Manish.
Uh, sir, sometimes what happens, we are having text as well as numerical data.
Mm-hmm.
And suppose we have to use a transformer model, and then how can we deal that?
So numerical values, like in the sense you are telling in the features.
Yes, sir. My means, suppose we are having text, and apart from text, we are also having numerical values. Like,
Not within text. So that is apart from, like, for example, like one column I'm having text, another
yes,
column I'm having some numerical information, right?
right.
Okay.
And we have
We,
to
yeah.
use transformer models.
Yes, yes. So in that case, what you can use is, like, since you have one feature is that is already numerical, okay. So you do not need to apply transformer to that particular feature. You can apply transformer to the textual data, okay. And once you have that textual information, okay, so then you can club those features as well, like from which you get the vectors from transformer. For example, like if I speak about bird, so bird would give you a vector, okay, so vector of particular dimension. So if you are having maybe 100 data points, so the dimension, rows dimensions will always be 100. So column dimensions will increase depending on the data which you have in textual. So once you have those feature data in output of a particular transformer, so you can use another feature, added features which was already there in your data. So you need not apply a transformer to the numerical data. You just apply transformer to the textual data and club those features once you have the output from BERT or other model, and then you can apply it to a machine learning or deep learning model.
Yes. Thank you very
So
much.
that is the way you can use.
Yes, thank you, sir. And sir, if somebody wants to start in cloud and deploying the models, deploying the NLP models, and then what should be the starting point? Yes,
So for cloud, so there are, you can say, like Amazon and Azure. So they both have, I think, you can say subscription, free subscription available for at least a year. Azure do have like 1 year subscription, and that is I think for students. I think it is more, and they do give some you can say amount as well in the subscription, which you can use to purchase their services on the portal. Okay, so you guys can try learning through cloud through maybe from YouTube. So and you can try it using Azure or AWS, and even Azure and AWS they have their training. Uh, you can say information or training data on the websites, which is free of cost. You can try using those, and you can learn using that particular part. So it might take some time, but that will be useful if you try yourself using those platforms.
thank you so much.
What I feel is like cloud is something like which is really taking place in like most of the companies. They are trying to deploy their model in the future, and they are moving from legacy to these cloud platforms.
Yes, yes, thank you so much.
Yes, Priya.
Hello, sir. Good afternoon.
Good afternoon.
Uh, sir, I want to ask about something.
Mm-hmm.
text processing kind of.
Yes, please.
For example, if we have a language which is very much complex and compound, which have compoundations,
Mm-hmm.
so and the translator is not available for that language. So if it is available, then it's very low accuracy that MT system is having.
Okay.
But what I want to do is NER.
Mm-hmm.
So for NER, uh, so since the translator is not available, so I was trying to transfer the text from the source language to the target language, and
Okay.
my source language is English.
Okay.
Um, uh, I have also tried from Hindi also, but for English and for Indian text,
Mm-hmm.
uh, the already I mean I would since the translator is not good, so I tried with word alignment tools.
Okay.
So, but the NER model for the English language is also for the Indian text is also not performing very well. I mean, for example, if for example, in Ramayana text, say
Mm-hmm.
from English to Sanskrit. So the so NER for I have tried Spacey,
Mm-hmm.
NLTK, and that's Stanford NER.
Okay.
So uh, so NLTK was performing the worst. Then comes Spacey, and then Stanford was good, better than the previous ones. But the Stanfords again is saying, for example, say Narad as some Narad, Mahर्षि Narad. It has not as name, but as some organization name. Uh,
Okay. Yes,
so
that might happen. Yeah. So, like, there are two things. Correct me, like, if I understood your question right. So, you're having problem in identifying the entities based on the information which you have from different Indian languages, and when you convert it to English, right?
no, sir. From yes, I want to have for different languages their NER models,
Mm-hmm.
but I will be transferring from English as so from source to target. So source will be my English
So you
because
want,
sophisticated system are available for English only.
yeah. So you have that particular text in English which you need to identify using NER, right?
Yes,
Okay. Yeah.
but that is also not performing. I mean, is there any library which is fine tuned for for Indian text for
So
writing?
Indian, yeah. So like there are two ways you can solve this particular problem. So since you are using English, so as you told, like you use Stanford and then NLTK and Spacey. So if you have a good amount of data in your hand, so you can train the Spacey model, like pre-trained model. For example, you might be using WebLG or WebSM model from Spacey. Okay, so you might train that particular model on your text. Okay, so in that case, what you have to do is you have to annotate the data that you have. You have to annotate the data with your entities that you want it to be recognized. Okay, so there are two ways which you can annotate. Is first is like if you are like Narad is one thing. Narad, you give it entity as a person. Okay, similar way when you have a good amount of data, so you can annotate it that using that. Another thing is you can do it using positional information. Okay, for example, Narad is one. So in this, so the starting position of Narad is 0 to maybe 5 or 6, and you can give that as a organizations, and you can use NER pipelines to further train the pre-existing model. So this is one way. Another thing
Okay.
is like if we do have any of the Indian languages library which is able to identify entities from that, so that would be the best option available. And I think, like as I was speaking to Manish, so there are libraries or the work that is ongoing on Indian languages. So I'll try to I'm forgetting the name, but I'll try to get that particular library or those resources. I'll text it to Manish, and he may further share it with you, so that I'll try to give it to you, so that
Sure.
you can use to identify. So that
Yeah.
these two techniques might be helpful for you.
Yeah. Thank you, sir. One more thing. I mean, I was using some word alignment tools. So first, I tried with Giza plus plus. Then
Mhm.
next, I tried fast aligner. So can you? But the accuracy still remains very low. So can you suggest some more good word alignment tool?
Aligner for finding, you can say, entities.
No, for giving corresponding words. This my source language is English.
Hmm.
then that word aligner will align the words for the target language, because the translator is not available for the target language.
Okay, okay. So for that you can okay. So that I'm not sure about aligners because I have not worked on aligners,
Yeah, yeah.
but I feel like if you find any of these Indian text work, so it will be easy for you to do that.
Yes, yes, sure, sir. Sir, one more question I have.
Yes, yes,
So,
please.
some of the words, while transliterating, I have seen that some of the words, for example, if we also have, I mean, commercially also these words came up. For example, if you see one medicine name, it's an Ayurvedic medicine, so uh, the name of that medicine is Ortho Aid, then
Hmm.
it's an oil. So in Hindi we call it tail. So TAIL. But
Hmm.
that company also in English it writes at TEL. So
Hmm.
similarly, jail is JAIL, but in English they wrote it as GEL. Sorry.
Hmm. Hmm.
So, but the standard embedding systems are not being aware of that. No, for for Hindi in jail, jame ki matra la, it's like JAIL.
Yes, yes.
So what? How can we handle, or
These
it
are
is
actually the
related
problems
to?
that is there with respect to if we speak particularly about different languages in and if we speak about like within Hindi or Indian languages, so you need to again use the Indian language embeddings if are there, and if they are not there, so then you need to create those embeddings. So once you are able to create the, so that is not a simple tasks that might take weeks or even months to because you need to have all the information, you need to have all the data, and then that will require a lot of manual efforts on that. Okay, so that's what I'm saying. Like if there is any Indian text information that is already available or embeddings there that are available, so that will be useful to you. Otherwise, like these are the problems which happen when we try to convert maybe from English to Hindi or other Indian language. So that is common.
Yes, yes, sir. Sure, sir. Thank you, sir. Thank you so much. Thank you, sir.
Anything else we can wrap up for the day? Manish or Vasudha?
Yes, sir. Vasudha?
Yes, sir.
Okay, so thank you so much. Thank you so much for giving me this opportunity to interact with you. And it was great interacting with you. And yeah, so
Thank you so much, sir, for your valuable time. I really appreciate it. Thank you so much.
thank you. Have a nice day. Bye.
Thank you.
Thank you, sir. It was pleasure to have so much knowledge, and you completed from the basics till the end. Means you started from the very beginning, from even the machine learning, and we were having the discussion on the latest transformer models as well. Therefore, we are very much thankful to you, and it was very enlightening session. Sometimes what happens, we are not aware with the industry what is happening,
Mhm.
and you covered all the things. Means what are the challenges in industry, and it was beyond our expectation, and we are really thankful to you.
Thank you, Manish. It was pleasure speaking with you guys.
Thank you, sir. And yes, recording is also there. We are having on it our YouTube channel of NITJ. We will be sharing it with you, sir.
Okay. Thank you, guys. Bye bye. Have a good day.
Thanks, sir. Thanks, Manisha, for the session.
Thank you, Nikhil. Thank you, sir.